Hello everyone. My topic of this podcast is high entropy alloy. I am Shubhro Kundu. For more than 5000 years, metals and alloys have been formed in roughly the same way, propelling civilization from the Bronze Age to Industrial Revolution and the Aerospace Age. Now there is a new technique on the horizon that could help us take another big leap forward. It's called high entropy alloying, and the latest focus issue of the Journal of Material Research showcases scientists and engineers' latest effort in understanding high entropy alloys and their potential applications. Traditional physical metallurgy uses an element with attractive properties as a base and adds small amount of other elements to improve the other properties. Over thousands of years, various elements have been used as a base. First copper, then iron, then one by one across the periodic table until researchers developed the first titanium alloy in the 1950s. It's a method that's proven incredibly effective, but there are signs that approach may be reaching its natural limit. But there are no new stable metallic elements to give new elemental alloy bases. That limitation has fueled research into high entropy alloys. Rather than basing alloys on a single element, high entropy alloy is concentrated blend of five or more principal elements to form an alloy base. Although HEAs were considered from theoretical standpoint as early as 1981 and 1996 and throughout 1980s, in 1995 Jean Wei Ye came up with his idea for ways of actually creating high entropy alloys in 1995 while driving through the Hsinchu, Taiwan countryside. Soon after, he decided to begin creating these special metal alloys in his lab, with Taiwan being the only region researching these alloys for over a decade. Most of the countries in Europe, United States, and other part the world lagged in development of HEAs. Significant research interest from other countries did not develop other 2004 until after 2004. Jian Wei Ye and his team of Taiwanese scientists invented and built the world's first high entropy alloy that can withstand extremely high temperature and pressure. Potential application include use in state of the art race cars, spacecraft, submarine nuclear reactors, jet aircraft, nuclear weapon, long range hypersonic missiles, and so on. A few months later, after the publication of Wei Ye's paper, another independent paper on high entropy alloys was published by another team from UK, composed of Brian Cantor, ITH Chang, P. Knight, and AJB Vincent. Ye was also the first to coin the term high entropy alloy. He attributed the configurational entropy as the mechanism stabilizing the solid solution phase. Cantor did the first work in the field in the 1970s and early 1980s, though he did not publish until 2004. Not knowing of Ye's work, he did not describe his new material as high entropy alloys, preferring the term multi-component alloys. The base alloy he developed, equiatomic FeCrMnNiCO, has been subjected of considerable work in the field, is known as Cantor alloy, with similar derivative known as Cantor alloys. Before classification of high entropy alloys and multi-component system as a separate class of nuclear materials and nuclear scientists had already studied a system that can now be classified as a high entropy alloy within nuclear fuels. The particle for nuclear fuel particle form a grain boundary and fission gas bubble. Understanding the behavior of these metal particles was specific interest to the medical industry, as TC99M is an important medical imaging isotope. Conceptually, this technique represents a shift in focus from the boundaries of a multi-component phase diagram to center. From fundamental studies on the formation of thermodynamic processing and mechanical and environmental properties of high entropy alloys to research examining their use in energy and defense application due to their high strength, superconductivity, and resistance to fatigue, fracture, corrosion, and irradiation.